Now let's discuss one sample t-test, and like we have done z-test, the calculations are almost same for one sample t-test. So one sample t-test will do when sample size is less than 30 and your population standard deviation is not known. So what you have to do in t-test, you have to use the sample standard deviation. Okay. Other things in the formula are same. For example, x bar is sample mean, mu is population mean, and n is the sample size, except for the sample standard deviation. So what we have done, we have substituted the population standard deviation with sample standard deviation. Now you'll use only sample standard deviation. So in other words, we can say if the population standard deviation is not known, we can go for t-test. And t-test, like z-test, you should not do when sample size is pretty small, like less than 30. But however, in practice, as you increase the sample size, like roughly around 200 or something, the result from t-test and z-test will be same. So one more thing which we do in t-test, which we calculate, is degree of freedom, df. So the corresponding value of p level or p value will be calculated based on t value and degree of freedom. So we'll see, and we'll have an example, and then we will calculate the t statistics and we'll do the t-test. So let's have this example 10.4. So Royal Tires has launched a new brand of tires for tractors and claims that under normal circumstances, the average life of the tires is 40,000 kilometers. A retailer wants to test this claim and has taken a random sample of 8 tires. He tests the life of the tires under normal circumstance. So the results obtained are presented in table. So these are the different values for 8 tires. So basically 8 tires is our sample size, that is n. And the life has been calculated for all 8 tires. These are the different values. For these values, we can calculate the mean. We can calculate the standard deviation of the sample. And as far as this value is considered, 40,000 kilometer, this is the standard value or value which has been claimed, and we should consider this value as the population mean, which is the previous experience or the claim made by the brand of tires. So we have to test whether the sample mean will be equal to 40,000 kilometers or not. So first let's frame our null hypothesis and the alternate hypothesis. So what we do, we can say null hypothesis H0, we can say that mean is equal to 40,000 kilometers. For alternate hypothesis H1, we can say the mean is not equal to 40,000, different from 40,000. So now we have framed our null hypothesis and alternate hypothesis. Second thing we'll do, choosing an appropriate test. Here population standard deviation is not given. Sample size is small, so that we can go for the t-test instead of a z-test. So let's do the calculations for a t-test. So t-test, first thing we do is to calculate the sample standard deviation. That will be this much, and I'll make a separate video if you do not know how to calculate the standard deviation for sample. sample mean also has been calculated here. So first you have to calculate these two values, sample standard deviation and sample mean, and then other things are already given. For example, population mean is given, sample size you already know, degree of freedom for one sample t-test we calculate sample size n minus 1. Here in our case it will be 7. So t-test statistics will be calculated using this formula, which is quite similar to the formula for Z statistics. So as we plug in all these values here, this is sample mean, this is population mean, this is sample standard deviation, and this is the size n. And then we calculate the value, it will be minus 0.27. Now what we do next is, as we were calculating the significance level, like our significance level was 0.05 and it was a two-tailed test, so it will be like alpha by 2. So what we do, we check the t value based on this information, alpha by 2, which is 0.025, and the degree of freedom, okay, and this t statistics. The t statistics we have calculated is what's that? Okay, in our case we have calculated it as minus 0.27 for value of alpha by 2, or say at 0.05 level of significance for a two-tailed test. What should be the value of t given degree of freedom is 7? So let's have a look at the t table, how we calculate the value of critical t value for t test. So here in the right side we have degree of freedom. So in our case, first of all, we will select this row which has our calculated degree of freedom, that is 7. Okay, so 7 is our degree of freedom. So we'll select only any value which is from only this row. Next thing we'll do is we'll see whether we are doing a two-tailed test or one-tailed test. We're doing a two-tailed test, so let's go for the 0.25. So we'll select this column, an intersection of this column and 7, we'll choose that value, and it will be this value, 2.365. so this is the critical value given degree of freedom as 7 and the significance level as 0.05 for two-tailed test. So sometimes what happens, you are not given this value of two-tailed test, your table is only one-tailed test, but the question you have been asked will be for two-tailed test. So what you need to do, you need to just divide it by 2. So when we are doing it for two-tailed test and the table we have got is only for one-tailed, so we just divide alpha by 2. In our case we had 0.05 as significance level, but suppose this line is missing, what you should do, divide it by 2, you'll get 0.025. okay, so in the present question we have 7 degree of freedom and 0.05 two-tailed test, and we'll get this value 2.365. so what should be the decision criteria? The value which we calculate should be greater than this value. If the value which we have calculated is greater than this value, we will reject the null hypothesis. Otherwise, we will not reject the null hypothesis. Let's go back and check it. So just let me clear everything. Okay, so now we have the decision criteria which says that it should be the t value should be if our value which we have calculated is greater than this value, then we can say null hypothesis is rejected. But in present case, the calculated value is way less than the critical value. So what we would say in this case is that we cannot reject the null hypothesis. Okay, So now we fail to reject the null hypothesis, or we cannot reject the null hypothesis, fail to reject the null hypothesis, or we cannot reject the null hypothesis because our calculated value is not greater than our calculated t value is not greater than the critical t value. I hope now you can calculate the values for one sample t-test, and you can make a decision based on this test. Thank you very much for watching this video.